we see that there is a circuit completed by this voltage source and there is resistor. So when there is a voltage applied at this independent voltage source, there should be a current, right? If the polarity, if let's say the voltage applied is 2 volts, a positive volts, right? Then the current should come out from the positive terminal, right? And it should go, according to this circuit, it should go anti-clockwise, right? But let's say if a minus voltage is applied, that means that the current should come out from the negative terminal, right? And it should go clockwise in this circuit. And the amount of current is given by, the amount of current I will be given by V by R1 in this case, right? Which is this resistance. All right. Now, in the first part, they have asked you to find out the resistance R1 such that if a 5-volt supply is applied, that will cause a current to flow in the circuit, right? So since it's 5 volt, that means the polarity will remain like this. So therefore, current should flow in the anti-clockwise direction like this, right? So therefore, this current is flowing through the magnetic field, right? And the magnetic field is into the page, and the magnetic field intensity is given here, which is 2.5 millitesla. And since a current is flowing through the magnetic field into this portion, which is 0.3 meter or 30 centimeter, a force will be applied by this magnetic field into the current carrying wire through this magnetic field, only in this portion, right? This portion. All right. Now we have to find the resistance R that will exert a force of 7.5 millinewton when a 5-volt source is applied. Now, for the first part, we have to use that since we know a current is flowing through a magnetic field and the force will be applied onto that wire, so therefore we have to use IL cross B formula, right? This basically tells you that if your current is flowing through a wire in a magnetic field, there should be a force, right? That's what basically this equation says. And since now you see the direction of the current carrying wire, right, and the direction of the magnetic field, it's perpendicular, right? Let's say if you consider this geometry to be in the xy plane as given by this uh, xyz plane, so therefore your circuit is in the xy plane, right? Your circuit is in the xy plane, but magnetic field is in the negative z, right? Because it's a cross, so that means it's in the negative z. So therefore you have already a 90-degree between the L and the B. So therefore, if you mathematically remove the cross, so then you have to put sine, right? Sine theta in this case is 90, so sine 90 is 1, right? So you end up having basically ILB, right? Now, since you applied a voltage 5, there should be a current, right? So that the current should be 5 by R1, right? This current you have to plug in here. You know the L. The L is basically the length with, to which the force will be applied. The force will be applied only at this length of the wire, this portion of the wire which is inside the magnetic field, right? So that is like 30 centimeter, but you have to convert it into meter, so that's like 0.3 meter. And you know your B, the magnetic field intensity, which is 2.5 millitesla, right? So now you know your F, that because you know you want to find the value of R1 such that 7.5 millinewton is applied, right? So therefore you have all the values. So basically your equation will be 7.5 millinewton. So that should be 10 power minus 3, 5 by R1 times 0.3 times 2.5 into 10 power minus 3, right? So now once you solve this equation, you will find your R1 to be 0.5 ohms. So that's the answer for part A. Now for part B, They have asked you to find out the direction in which the wire is displaced if a voltage of 2 volts is applied, right? So if you even apply 2 volts, right, so the current will be in the same direction, right? Because the current is in the previously it was also positive, so now it's also positive volts. So the current is flowing, but the amount of current will be different, right? Because I is equal to V by R, so the amount of R1, so the amount of current will be different, but nonetheless the direction will be the same, right? So now you know the direction of the current, which is going to the left, right? You know the direction of the magnetic field, which is going into the page, right? So therefore you have to find the direction of the force, right? The force that will be given by this equation, right? So now you have to use the Fleming's right hand rule, which basically says that if you have a current flowing in a magnetic field, then there will be a force applied perpendicular to the plane where the current and the magnetic field is flowing, right? So this basically tells you, this is given by the Fleming's right hand rule. So now you place your uh, index finger into the direction of the current, you place your middle finger in the direction of the magnetic field into this diagram. So therefore your thumb should point out the direction of the force, which is, if you apply, you will see this is of course the right hand, for the right hand, right? So then you will see that the direction of the force is in the downward direction, that means in the negative y-axis direction. Now this question is continued till to another circuit. This is shown here. So there basically you have two different circuits, right? The one circuit is similar as before, that you have a voltage source applied and a current will flow when the voltage source will be applied because of this resistance, right? The amount of current will be given by the applied voltage and the resistance, and the direction of the current will be determined by the polarity of the voltage, right? If it's positive, it will be in the downward direction, anti-clockwise. If it's negative, it will be clockwise direction, the current will be flowing, right? Now you are asked in part C, right? In part C, you are asked to find out that if a minus 5 volt is applied, right? So you have applied a minus 5 volt, so that means the current will be coming upwards, right? The current will be coming upwards and going like this through the resistance R1, right? Now you have to find out the direction of the magnetic field at the center of the loop, right? So you have to find out, since you have another loop here, so you have to find out basically, let's say, because of this current flowing, what will be the direction of the magnetic field at the center, at this point, right? The center of this loop. Now you, for this one, you have what you have a current carrying wire, right? And you know the direction of the current. So here you will use the right hand grip rule, right? So if you point your thumb to the direction of the current at this region, then the curl of your fingers should point out the direction of the magnetic field, so it should curl like this, right? So you see that for a current carrying wire on the left, you will have a magnetic field direction curling up like this. So that means it's curling the direction of the magnetic field at the center of the loop, right? At this position is in the positive z-axis direction according to this convention, right? Because the magnetic field loop is like this. So therefore it's in the positive z-axis direction. All right. Now in part D, what they have asked you to find is that if Vt, now that means now right now Vt is not minus 5, so this is a different scenario entirely, right? So they have asked you to find that if your Vt increases from 0 to 5 volt, that means your Vt is increasing positively, right? So that means throughout this period when your voltage is increasing from 0 to 5 volts, you will have a current flowing like this, right? You will have a current flowing like this in the anti-clockwise direction. So over a period of 1 second, right? So that means over a period of, let's say, if I plot this time versus voltage, right? So over a period of 1 second, I have a voltage increase from 0 volts to 5 volts, right? So now what will be the direction of the electromagnetic force generated in the wire loop? So that means, let's understand the problem. So as we are increasing the voltage, there will be an increasing current, right? Let's say I'm increasing the voltage. I'm increasing the voltage from 0 to 5 volts. So what happens? Since I know my current is proportional to the voltage, right? Because R1 is fixed. So as my voltage is increasing, my current should also increase, right? So that means as I am increasing my voltage, my current is increasing, right? My current is increasing. Now this increasing current will generate through the right hand grip rule a magnetic field at the center, at this position, right? And since now if you point your thumb to the right, you will see that your magnetic field, right? Your magnetic field is curling like this right now, right? So that means your magnetic field is going in the negative z-axis direction for the center of the loop, right? At this center, you have a magnetic field going in the minus z direction. Now, as you are increasing the voltage, the current is increasing. So that means you have an increasing magnetic field in the minus z direction, right? So now this increasing magnetic field, changing magnetic field will cause an EMF to generate in this loop, right? But what that EMF will try through the Lenz's law, right? So what was Lenz's law? The EMF generated is basically minus n d phi b by dt, right? So as you increasing the current, right? This current, as you're increasing the voltage, this current, right? This current is increasing. So this magnetic field for the center, I mean this magnetic field at the center position, right? At this center position, which is the magnetic flux phi b, this is changing with time, right? Because you see, you are changing voltage with time. So if you're changing voltage with time, current is also changing. So therefore, magnetic field is changing, right? If you're increasing the voltage, current is increasing, magnetic field is increasing. So as your phi b is increasing, right? So therefore, your phi b is increasing, right? But the number of loop, the number of turn is equal to 1, right? So basically we have minus d phi b by dt, right? So basically this minus sign is because of the Lenz's law, right? So now since you have, let's say, let me redraw the circuit. This is the loop, right? This is the loop, and this is your R2. So since now you have an increasing magnetic field in the negative x-axis direction, right? So therefore I'll just put cross, right? I just put cross. Since your magnetic field is increasing in the negative z-axis direction, right? So what will happen? The current generated in this loop will try to reduce the magnetic field increase into the page, right? So that means the current should generate in such a way that it will try to reduce this magnetic field. That means a current will be generated such that the generated magnetic field will be coming out of the page, right? So since it's coming out of the page, it will cancel the going into the page magnetic field for this loop, and it will reduce, right? So that's what basically Lenz's law says. So that means you want your magnetic field to come out of the page, right? The induced magnetic field to come out of the page. So for that one, if you curl your right hand fingers as a grip rule, you will see that the direction of the current, right, has to be in the clockwise direction, anti-clockwise direction, right? Because in this case, your magnetic field has to curl upwards, right? So for that to happen, if you apply the right hand grip rule, if these are your fingers, then the thumb should point in the right hand direction. So that means counterclockwise current direction, right? So therefore, your option number 2 is the correct option. Now let's proceed to question number 2. So now this is a circuit given, and you are asked to find out the voltage Vx in the circuit, right? That's the first part, and then you are supposed to find out the power absorbed or supplied by resistance RL, the independent voltage source, which is the 10-volt source, and also by the independent voltage source, which is given by 4Vx. Right. So now, since you have to find out Vx in this circuit, and they have not asked you, you are free to use mesh or nodal analysis in this case. Right. So I'll just do first by nodal analysis. So first, you have to find out when you want to compute the Vx. So the first thing you have to find out is the number of nodes, right? So let's say you assume that there are 3 nodes, right? Node number A, node B, and the node C. But you already know the voltage at node A, right? Because your ground is given. So you know the voltage at node A, so which is 10 volt, right? So basically you have 2 unknown nodes, right? You have 2 unknown nodes, which is VB and VC. So you need to find 2 equations, right? So it's a 2 variable equation. Now, uh, once you find out the equation in terms of VB and VC, you will see that your equation contains also Vx, right? Because this is a dependent source Vx. Now, what's your Vx? You see, Vx is basically this nodal voltage, the difference between this nodal voltage and this nodal voltage, right? So basically VC and VA. So basically what's your Vx? Vx is basically VC minus VA. And since you know your VA, which is 10 volts, so your basically Vx is basically VC minus 10, right? So once you find your equation in terms of VB and VC, you have to replace all the Vx by this equation. So then you will have completely 2 equations with only 2 variables. Otherwise, you will end up having a third variable Vx, right? Okay, so let's proceed. So since we know that we have to find 2 equations for the 2 unknown nodes VB and VC, so let's proceed by analyzing node B, right? Let's proceed by analyzing node B. So for the node B, uh, I assume that the current is going out, right? Current is going out, and since you see between node B and node C, which are your unknown nodes, you have a dependent voltage source. So this forms a super node, right? So I have to combine these 2 nodes together. So that means if I want to find out the nodal equation at node B, I have to consider a super node. So let me just write the first equation that the current is going out. So since the current is going out at node B at 2 points, because I'll not consider the current going into the super node, because the current going into the super node from node B and node C will cancel each other out, right? So therefore I'll not consider the current going inside. So I'll just consider the current going on the other branches. So I end up having 1, 2, 3, 4 current equations, right? So let me just write these equations. So if I want to proceed, it's VB minus 10 divided by 1K. This is the I1, right? This is this current I1 plus VB by 1K, right? This is I2 plus, now I go to node number C, right? So this is I3, which is VC by 1K, which is RL, right? Plus I4, which is VC, right? VC minus 10 divided by 1K, right? So this is my first equation. This is my first equation. And at the super node, I have to find another equation, right? So if this is my VB, for Vx, Vc, right? So what will be my second super node equation? So that's just applying KVL, right? So this basically says that my Vc minus Vb is equal to 4 Vx, is equal to 4 Vx. And what is my Vx? Vx is basically Vc minus 10, right? So Vc minus Vb equal to 4 times Vc minus 10. So this is my first equation. This is my second equation. So for two unknown nodes, I have already two equations, right? So now I can just solve these two equations to find out what's my VA, VB, and I know my VA, so what's going to be my VB or VC, right? So by solving this equation, I find my VB to be minus 5 volts and VC to be 15 volts. All right, and I know my VA, which is already 10 volts, right? So now, since I know all my three node voltages, I can proceed to find out the rest of the parts, B, C, and D parts, right? All right, so let me write down the voltages. VA is basically 10 volts, VB is minus 5 volts, VC is 15 volts, and we know that our Vx is basically Vc minus 10, which is equal to 15 minus 10, which is basically 5 volts, right? So we know the voltages at all the node points right now. Now for part B is that you have to find out the power absorbed or supplied by the resistance RL, right? So for that one, I can use, since the voltage across the RL is basically VC, right? Because that's the nodal voltage, and we know the voltage at this point is 0 volts, right? So basically the voltage across VRL, basically VRL is basically VC minus 0, which is equal to VC, right? So if I know my VRL, I can know my PRL, right? Which is basically VRL squared divided by RL, right? So in this case, it's just VC squared by RL. In this case is 15 squared, right? 15 squared by 1 kilo ohms. And now I find that this power is basically positive. That means it's an absorbed power, right? That means the current is entering like this. So that means the current is entering to the positive terminal of the voltage. That means this power is absorbed by RL. Now for part C, we have to find out the power absorbed or supplied by the independent voltage source, right? So we have to find out the current through the independent voltage source, right? So let's find out this IS, right? Let's find out this IS. So now this IS will be split up into this one, right? Let's call this I1, and let's call this I2, right? So this IS will be split up into I1 and I2. So what's gonna be my I1? I1 is basically VA minus VB divided by 1K, right? I can find it out. What's my I2? I2 is basically VA minus VC by 1K, right? So once I plug in the values, I find that my IS is equal to I1 plus I2, which is basically is equal to 10 milliamps, right? So that means since my current is positive, that means this direction that I assumed is correct. So that means I have 10 milliamperes going through the negative terminal of the source. So for this one, my power should be negative, right? So voltage Vs times Is, which should be, since it's going through the negative terminal, that's why the negative is placed, 10 times 10 milliamps, which should be equal to minus 100 milliwatts. Since the power is negative, so therefore the power is supplied by this source. For the part D, you have to find out the power absorbed or supplied by the dependent voltage source, right? So for that same thing, you have to find out the current through the dependent source. So let me term this as Ix, right? So therefore this I1 is split up into, let's say, I3, which is the current through this 1 kilo ohms, and Ix, right? So therefore the I1 should be split up into I3 plus Ix. Now we have to find out Ix, right? Now what's my I3? I3 is basically VB by 1K, right? VB by 1K, and I know my I1, right? So basically I can find my Ix, and if I find my Ix, it's gonna be 20 milliamps, right? So what's my Px? It's, and since this current is positive, so that means we have the direction we assumed is correct. So that means 20 milliampere is flowing through the negative terminal of the dependent voltage source. So that means the power should be supplied, right? Because it's gonna be negative. So the power is basically 20 times 20 milliamps, right? How I know the voltage this is 20? Because what's my Vx? Vx is 5 volts, right? And what's the voltage source here? 4 Vx. So that means this is 4 times 5, right? 4 times 5, this is 20 volts. So that means current is entering through the negative 20 volt dependent source, and the power is basically minus 400 milliwatt, right? So since this power is also negative, so therefore the power is supplied by the dependent voltage source. Now I can also proceed this problem with the mesh analysis, right? So for the mesh analysis, there are 3 loops, no super meshes, right? So I can assume this is gonna be my current I1, this is gonna be my current I3, and this is gonna be my current I2, right? So since I have 3 loops, 3 unknown variables I1, I2, and I3, I can find out 3 equations, right? So I'll just write the mesh equations. So what's gonna be my Vx? My Vx is gonna be minus I3 times 1K, right? Why minus? Because the current is entering through the minus terminal, right? So wherever in the equation I will have Vx, I will just replace Vx with this term, right? So let's do for mesh 1, that is for loop 1, right? So let's do for I1, this loop, right? So when I'm assuming mesh 1, I'm assuming my mesh current I1 is greater than all the other currents, right? So what will be my equation? It's gonna be minus 10 plus 1K times I1 minus I3 plus 1K I1 minus I2 is equal to 0. So for mesh 2, I'm considering my current I2 to be greater than all the other currents, right? So therefore it's I2 minus I1 times 1K to okay, so that's minus 4 Vx, right? Plus 1K times I2 is equal to 0. So now I'll replace this portion in this term, right? So I will have basically I2 minus I1, 1K, the minus minus will cancel, so it's gonna be plus 4 I3 1K plus I2 1K equal to 0. So for the mesh 3, I'll consider I3 is greater than all the other currents, right? So it's gonna be plus 4 Vx plus 1K I3 minus I1, right? Plus I3 1K is equal to 0. So now I'm gonna replace Vx by this minus I3 again, right? So it's gonna be minus 4 I3 1K plus 1K I3 minus I1 plus I3 1K is equal to 0. So you have 3 equations, right? You have 3 equations, 3 variables, solve the 3 variable equations, find I1, I2, and I3 in this case, right? So in this case, your I3 is gonna be minus 5 milliamps. I2 is gonna be 15 milliamps, and I1 is gonna be 10 milliamps. So once you have the current values, you can find out the voltages, find out the power, and it should give you the same results as we did for the nodal analysis. Part of the last question of the exam. So for this one, it has two parts and it considers linearity. So basically this is the first part where they have asked you to find out I naught using the scaling property of the linear systems, right? So in this case, you assume that you start by assuming that your I naught is 1 milliamps, right? So you start by assuming that your I naught is 1 milliamps, right? So by assuming I naught is equal to 1 milliamps, you trace back to find out what's gonna be your Vs. What's your Vs? What should be your Vs if your I naught is 1 milliamps, right? So now let's find it out. So since we assume that 1 milliampere is flowing through this 4K resistor, so what's gonna be the voltage across this 4K resistance? Let's term it as V1, right? So what's my V1? V1 is basically 4 kilo ohms times 1 milliamps, which is equal to 4 volts, right? So since this 4K and this 4K are parallel, so therefore I have the same voltage V1 through this, right? And I have the same voltage across this complete 4K, right? So if I term this current going through this 4K is I1 and term this current going as I2, so I can find my I1 and I2, right? So my I1 should be 4 volts divided by 4K, should be 1 milliamps, right? Similarly, my I2 should be 4 by 4K, also 1 milliamps, right? So since I know I1, I2 to be 1 milliamps, and I also know I assume that I naught is also 1 milliamps, so basically I can find out my I3, right? So I3 is being split into three portions, I1, I2, and I naught, right? At this node, case by KCL. So what's gonna be my I3? My I3 is gonna be I1 plus I naught plus I2, which is equal to 3 milliamps, right? So if I know 3 milliampere is flowing through this one, I know the voltage across this resistance, which is supposed to be V1, right? So I can find out what's the voltage drop across this resistance, which is V2, right? So what's my V2? My V2 is gonna be 2 kilo ohms multiplied by 3 milliamps, right? So that should be 6 volts, right? So if I know the voltage across this is 6 volt, the voltage across this resistance is 4 volts, so I can apply a KVL, right? KVL like this in this loop, right? So by applying KVL, I end up having minus Vs plus V2 plus V1, right? Because right now I have, let's say, this is my Vs, this is my V2, and this is my V1, right? So I can apply a KVL is equal to 0. So by applying a KVL, I find that my Vs is supposed to be 10 volt, right? Vs is supposed to be 10 volt if I assume a 1 milliampere current is flowing in this I naught branch, right? But what's the actual voltage I have? It's 12 volts, right? So that means the actual volt is basically 1.2 times greater than this voltage, right? So the actual voltage is 12 volts. So that means since you multiplied by 1.2, you have to multiply this also by 1.2. So that means your actual current is 1.2 milliamps, right? So that's the scaling property. That's the scaling property, right? All right. Now let's go to part B. Here they have asked you to find out the additive property, right? So this is basically the superposition. So since for superposition you have to find out how many independent sources you have. So number of independent sources will give you the number of circuits that you have to solve. And when you are solving for a voltage source, you have to turn off all the other sources. And if it's a voltage source, turning off, it will be short circuit, current source, open circuit, right? All right. So now we are gonna have, let's say, we are gonna find I naught using the superposition theorem, right? So basically, let's consider two circuits. One is the 12 volts, the 12 volt off. The other one, let's consider 4 milliamperes. 4 milliamperes off, right? So if I am considering 12 volts off, so that means I'm turning off my voltage source. So turning off my voltage source means it will be a short circuit, right? It will be a short circuit. This is my 2 kilo ohms. So the only source I have in the circuit is just the current source. Right, so that's gonna be my circuit, and for this circuit I have to find out I naught prime, right? So this is the I naught prime is the current solely because of this dependent current source. So now if I turn off the current source, now if you consider the 4 milliampere current source to be off, that means you have only one source, which is the independent voltage source, right? So now when you turn off the current source, you replace it with the open circuit, right? So now you replace that with the open circuit. That means nothing is there at the top, right? So this is the 4 kilo ohms. Right. So now you can use nodal analysis or mesh analysis, right? In both the circuits to find out I naught and I naught prime, right? So at the end, your final results should be the actual I naught should be I naught prime, which is because of the contribution from the current source only, plus I naught double prime, which is the contribution because of the voltage source only, right? So if you solve both the circuits, like for example for the I naught prime for this circuit, right? So I can just skip the calculation, because if you would notice, this is the same circuit as from part A, right? It's just the same circuit, and since I know from part A the current is 1.2 milliamperes, so I can write, because I don't want to repeat the calculation, so I can write my I naught double prime is 1.2 milliamps, right? So for now, for I naught prime, I can just use nodal analysis, right? So if I want to have nodal analysis, how many nodes I have here? If I consider this to be the ground, how many nodes I have? I have one node, which I can term V1. Then I have two nodes, which I can term V2, right? So if I route, and since I have no super nodes, right? Since I have no super nodes, I can write the nodal equations, right? So what's going to be my nodal equation? Since there are two nodes, I need, and these two nodes have two unknown voltages, I need two equations. So what's going to be my first equation at node 1, right? At node 1, this is my first equation, right? So that the equation will be, I'm assuming current going out in all the directions, right? Current going out in all the directions, right? So what's going to be my node 1 equations? Is going to be V1 by 2k plus V1 by 4k plus 4 milliamperes, right? This is the current going out. So 4 milliamps plus V1 minus V2 divided by 2K, right? Which is this current direction. I have 4 currents is equal to 0. So that's my first equation. And at node 2, I'm going to have my second equation, which is basically also current going out, right? Current going out. So it's going to be V2 by 2K plus V2 minus V1 by 2K. And since this current direction and the original direction is opposite, so I consider minus 4 milliamps is equal to 0. So two nodes, two unknown voltages, two equations. So once you solve these two equations, you will find that your V1 is basically minus 1.6 volts and your V2 is 3.2 volts, right? So what's gonna be your I naught prime, right? So what's gonna be your I naught prime? It's this current, right? So this current is basically V1, right? This is the V1, because the voltage is V1 and this voltage is 0, right? So it's just basically V1 by 4K, right? So which is just basically minus 0.4 milliamps. So what's gonna be my I naught? I naught is gonna be minus 0.4 plus 1.2 milliamps, right? These are milliamps. So my I naught is just 0.8 milliamperes.